Hello everyone, welcome to this video. In this video we'll be talking about a result which states that order of an element divides the order of a finite cyclic group. So obviously I have mentioned here that for a finite cyclic group, what is the relationship between order of an element and the order of this group, and this result holds only and only if when we have finite cyclic group with us, right? So the group should have these two properties, then only we can apply this particular result over here. So here the result states that the order of the element that divides the order of the group. Let's see how this thing is there. For the proof here, we suppose that G is such a finite cyclic group, right, having generator as A. So therefore we may write this group G as equal to the subgroup which is generated by A, right? And we now suppose that the order of this element A is equal to n. If that is so, then n is the smallest positive integer such that when you take a to the power n, that is equal to the identity of the group which is represented by E. So the order of group G is basically the order of the subgroup generated by A, and we have studied about this result that the order of the subgroup generated by A is equal to the order of the element itself. In the previous results you may check that, and the order of A is n. So basically the order of group G, that is n, right? Now we suppose that if B is some element which is present in this group G, then this B could be written as a to the power k, right? Because we are taking B from the finite cyclic group, so it would be, because A is the generator, so it could be written as some power of A, right? And so this power is k, so this power is obviously less than the order of the element and it is greater than or equal to 1. So we are now interested to see what is the order of this element B. So the order of this element B is the order of a to the power k, and according to the result that we have studied in the previous video, a to the power k has order n divided by the GCD of n by k, n with k, where what is this n? N was the order of the element A, right? So in this case also n is the order of A. So we have this result here, and we say that this thing is equal to some natural number which is j, right? This is by, we are assuming that this is equal to j. So accordingly, if you see this expression here, from this expression you can have the value of n. This is n multiplied with the GCD of n and k, right? So that means this j divides n. Why? Because this is some number. So from here you see n is a multiple of j, or in other words you can say that this j divides n. So this j divides n, and what was j? J, from here you can see this j was the order of the element B, and what was n? N was the order of the given group, right? So that means the order of the given element divides the order of the finite cyclic group in this case. So this is the proof of this theorem. So I hope you understood this result. Well, that is it for this video. Thank you for watching.